All right, good morning, everybody. And welcome to using AWS networking and logging features to enhance security. I'm Nathan McWirt, Senior Solution Architect with AWS.
And I'm Dave Rogers. I'm Head of Architecture and Security at the UK Ministry of Justice.
So expectations and a high-level agenda for the talk. My expectation is that you've got a background in networking and a little bit of an understanding of some of the networking features in AWS, a familiarity. We're going to be talking about a lot of services kind of at a high level and some techniques around those and how you might use them to improve the security. What we're really going to do is take you on a little bit of a journey this morning and start from kind of where we're coming from, what traditional network security often looks like, into some of the tools and techniques that you can use to improve that, and then a higher level look at what that does for processes and application security at a much higher level. So we'll start from the beginning and talk about managing traditional networks is hard. You have limited visibility, right? Your control of the network is distributed across a variety of switches and routers. They're in different places. They're often built by different manufacturers, different operating system versions. They're not consistent. And that's your point of control and your point of visibility over the network. When you want to know how things are configured, you go and you connect to the device that owns that piece of the configuration, and you inspect it. Or if you can't get it from the device, sometimes it even involves somebody with a clipboard walking to a building and chasing a cable to go, what on earth is on switch port 32 and why isn't it working properly? So verification in these environments of our configuration is often infrequent. It turns into sometimes a yearly audit process to actually really go out and look at how is the network configured and what do the ACLs look like. And that means that because it's not centralized, because it's on all these different devices, and we have to go out and connect to them and kind of manually inspect them, that becomes very difficult. Automation is really hard to do, and when we can do automation, it becomes really fragile because we're integrating a lot of kind of disparate devices that weren't all necessarily made to work together, or when they do, it's sometimes a really heavy lift to configure them to all play nicely so that we can monitor and manage them. The other side of that is control, right? We talked a little bit about managing access. In theory, it's possible to take all these devices across your network and tie them together in some kind of centralized AAA through LDAP or some other kind of identity management. But it's often difficult. It's often a really heavy lift. It doesn't always work right. And changes are really difficult to control and keep track of in this environment as well. Most environments, at least the ones I've dealt with in my career, are manually configured. In environments where we need that to be very tightly controlled, we add an additional manual change control process around it and go, all right, you're going to make the manual change, but now you need 4 signatures to do it, and you're going to log in at 1 o'clock in the morning and you're going to make the change. And kind of the last piece around that is the network doesn't tell us when things change. Monitoring for configuration changes often involves, again, back to that visibility problem of somebody having to go manually verify configurations, or maybe if they're all centralized and stored on one server, you can go kind of look through them and go, okay, check this matches, everything is what it's supposed to be. There's ways to build automation about that, but it's a heavy lift and it's often fragile. So when we start talking about traditional networks and network security, we get this, this meme has been used over and over, and it will be used again, right? The crunchy exterior and the soft center. That's a Tootsie Pop if nobody recognizes what that piece of candy is. So this is kind of a well-known problem, and it's talked about in network security a lot. A lot of times we have a kind of myopic focus on the edge of the network. Something, kind of an anti-pattern I like to call security by procurement instead of security by design, right? We focus hugely on the edge. We get lots and lots of big, expensive network defense equipment, and we put it at the edge of our network, and we have a lot of faith that this big, expensive network equipment is keeping us safe. On the inside of the network, things are a little softer and squishier typically. We have big Ethernet networks is usually what we're talking about when we're talking about data center networks, right? We have multi-tier applications that are split up into a couple of really big VLANs, and we say, all right, well, the application server for the public-facing CMS goes in the app server tier. The application server for the accounting system goes in the app server tier. And they all live in there together, and we do network enforcement in between those tiers. But the environment that creates is you have a lot of applications that don't necessarily have any need to talk to each other that all live together in the same network. They create risk for one another. So you've got limited isolation between those. If the public-facing CMS system becomes compromised, right, because we plan for compromise in our network, we plan that things are going to get broken into. So if that public-facing CMS system gets broken into, it has no need to communicate with its neighbor that sits right next to it. But from a least privilege and a best practice perspective, is there actually filtering going on there? Is there anything stopping this compromised server from attacking everything else on its tier? And if it begins doing that, do we know? So, and there's other kind of lower level network attacks we have to worry about in this environment, just by nature of the level 2 networking we're most frequently using. There's all sorts of very well-known attacks like ARP spoofing and ARP cache poisoning, VLAN hopping, and various other things that go on. Best practice is, at this level, we should be using host-based firewalls. We all know we should be using host-based firewalls. They should be turned on. It's almost everybody's got a security control around that. But it's got limited visibility, and it's difficult to manage. If you have 1,000 machines, that's 1,000 machines that you need to monitor to make sure the firewall's enabled. You need to monitor to make sure that the rules are configured in a way that's actually least privilege and defense in depth for the servers that are involved. And that's hard. It's a heavy lift. It's difficult to automate. And the other side of that is change control continues to be difficult. So when we talk about accidental changes to the network, or maybe purposeful changes to the network. If somebody accidentally moves a database server into the DMZ and it doesn't get noticed for 2 days until somebody realizes their development system isn't working, how do we know that happened? How do we deal with that? If somebody then finds the issue and corrects it by moving this database server back into our database tier with the rest of our production or even development workloads after it's been exposed to who knows what, how do we know that happened? Is there a process around it? Can we kind of control that risk that these configuration changes are going to happen? So, again, there's a lot of best practices around this, right? We should be running port security, but it usually involves a lot of manual processes, and it can be difficult to manage. We ought to be doing 802.1x, right, as a best practice in a lot of networks, and some it's required. But again, it's difficult to configure and maintain, and it slows down velocity. So let's talk a little bit about how these things are different, how you can get away from some of these difficult patterns, how you can do things in a more secure fashion, faster, better velocity, faster, better, cheaper, right, in this environment. So first, I want to talk a little bit about some network enforcement tools. And we're going to start at the very, very, very bottom of networking in AWS and talk about Amazon VPC, Virtual Private Cloud. So this becomes kind of the baseline and the prerequisite for almost all networking. If you're not super familiar with Virtual Private Cloud, it gives you the ability to create isolated networks in the cloud environment that you can put your resources in. And almost everything we're going to talk about either is a configuration on or is something that you put in a VPC. So this slide may look familiar to some of you. I borrowed it from another talk. I'm going to give you the 30-second overview of a really great talk called A Day in the Life of a Billion Packets and Another Day, Another Billion Packets from the last 2 reInvents given by a gentleman named Eric Brandwein. I highly recommend, if you want to geek out on some deep network stuff, that you go watch those talks. I'm going to give you just a little bit of flavor of what really happens here. So we'll start off talking about VPC to say that VPC is not Ethernet, I think is the most interesting place to start. We get asked sometimes by customers, they go, VPC, it's VLANs, right? It looks like VLANs. It's not VLANs. It's not VRFs either. Part of the reason for that is that those just don't scale, right? You can only have 1,024 VLANs and you run out of bits. We have a lot more than 1,024 VPCs. The other problem is that Ethernet doesn't necessarily scale to multiple physical facilities and large high-speed networks. So what we've really done with VPC is we've re-implemented Ethernet as a layer 3 distributed service. And we'll talk a little bit about what that looks like. And again, I encourage you to go see those talks. I tell all my network friends to go check them out. So when a machine in a VPC, what we've got here in this diagram, if it's not super clear, is the machines in blue are guest operating systems. They're instances that are part of one VPC. The machines in green are guest operating systems from another VPC. And the big machines in gray are host servers that are some piece of hardware in a physical facility somewhere. So what happens is when a guest operating system wants to send a packet to another machine in its VPC that looks like it's in its private network, it sends the packet. It has an Ethernet adapter. We emulate the Ethernet for it, even though there's not really any Ethernet here. You can't communicate layer 2 between instances within a VPC. The host around it receives that over the kind of simulated Ethernet interface, right? And it needs to figure out where that packet belongs because it goes to another instance that may be in another physical data center, right? It might be in another availability zone. So the first thing it does is it talks to the mapping service and it says, hey, this packet is destined for this other machine in the VPC. Where is that machine? Where do I send this traffic? Mapping service gives it a response. It now knows where to send it. It says, oh, it's down at this host over here, wherever that host happens to be, and it sends it across the big layer 3 network to the other host where that traffic belongs. The host that receives it doesn't automatically just accept it. We do two-way verification. So the host on the receiving side says, hey, I've got packets here that say that they're addressed from this host, this instance, and it should be delivered. Does this all match up? Is this instance in the same VPC I'm in? Does everything look kind of copacetic? If it gets verification of that and it all looks good, it's delivered. The instances don't know this happened. To them, they think they're all on the same network. They think that they're speaking layer 2. They have kind of emulated Ethernet devices. But VPC tunnels and manages that traffic, and that's how we kind of create that abstraction to be able to create a virtual network that scales across physical facilities, but still looks and feels in many ways like the kind of networks you're used to configuring. A lot of the concepts are the same. So what does this do for us, and why is it so important? Consolidation becomes a big part of this. So with VPC and with the other tools we're going to talk about, this is all consolidated into one API. We're not going out and talking to a bunch of different routers and switches and other network hardware that's in a bunch of different places to gather our configuration. It's all in one place. It's behind an incredibly hardened API with a stable interface that you can program against, that you can automate against, that you can build auditing against. That API comes with identity and access management, right? We've got this rich policy language that lets you define who can do what in the network. You can use that to do things like implement separation of concerns and say that the development team can create firewall rules in their security groups, which we'll talk about security groups in a little bit, but they can't control the routing and they can't control the ACL, so they can't make a DMZ into a more private subnet, or they can't take an internal subnet and open it to the internet, right? Because that requires a set of controls that have been granted to somebody else. We talked a little bit about automation, right? But we can automate that. When we start talking at a high level about doing things like DevOps and iterating rapidly, a lot of these network controls, they can be automated, so they can be built into your deployment pipeline so that you can have the very isolated, controlled networking environment without giving up agility and velocity, because you can tie all this together and you can deploy these very strict networking constructs along with your code and along with your applications. So you don't have to choose one or the other. Visibility is another thing, and this will be true. We'll talk about this over and over. This will be true of a lot of the services we're going to look at, that you have almost instant ability to request what's in the environment. You want a list of your instances. That's a single API call. That used to be a job somebody used to have to go wander around data centers with a clipboard, right? This was an asset control problem. What servers are on the network? Now it's, give me a list of the servers on the network, and in minutes you're done. Here's a list of every server on the network, period. So that becomes a really powerful tool. So now we're going to get into some of the more specific tools and kind of build our way up. So the other one we're going to spend a lot of time on. We're going to spend a lot of time on VPC and security groups, and then the others we'll move through a little more rapidly. So security groups, I think, are unique, and I want to call out some of the reasons why they're unique. Security groups are stateful firewalls. They are implicit deny, explicit allow, so you got allow rules, and anything that's not explicitly allowed is denied. And they're mandatory. You can't run an instance without a security group. We make you configure a security group. You can open it to the world if you choose to, but you have to use one. Every instance has one. The other neat thing about security groups that I think makes them a lot more powerful than some of the more traditional types of packet filtering that were available to us is security groups can reference one another. So if you look at the example in the slide, let's say those 3 servers at the top, maybe your web servers in some mythical application, and the 2 at the bottom are database servers in that same application. What we've done is I've allowed inbound web traffic to those web servers from the world, because we want the world to be able to reach this web application. But the interaction between that group and the group below it is we're saying, well, allow outbound traffic on the SQL port to database servers, not a list of IP addresses, but the actual security group. So what that's saying is any web server can send traffic on the database port to database servers. And the same thing on the database server group. We're saying allow inbound database connections from the web server group. What that means is we can do really, really detailed port filtering. We can say you do not talk to your neighbor. You do not talk to other applications. You talk to these machines on these ports, but in a way that when I go to add a new machine to my environment, I don't have to go modify all my firewall rules to add the new IP for the new database server, right? That's part of why this used to be a really hard thing to do at this level. So I think the other thing I want to call out is that security groups will stack. So a machine can be a member of more than one security groups. And sometimes the nomenclature security group is confusing. I recommend customers think of them as groups of firewall rules, not groups of servers, right? They're templates of firewall rules that apply to instances individually rather than a group that you put instances in. So because of that, you can stack, you can stack security groups. Instances can be members of multiple security groups. So you lead to this pattern that I really like that I call role-based security groups, where you say, well, I'm going to have, like, I used Active Directory here. Let's say this is a Windows application. I used Active Directory here as an example because Active Directory has a really long list of ports, and some of them are pretty privileged ports, and in a lot of your networks, you're required to control pretty tightly. So you can get into this model where you say, all right, well, I'm going to put all those in a group together, and I'm going to treat this like a role. I'm going to say this is for Active Directory clients, and this is for database servers, and this is for web servers. And then when you launch a machine and you create a machine in that network, you can say, well, this machine is a web server and it's a member of Active Directory, and you can tag those groups to it, and each of them will give it permissions to talk to things on the network that it should have permission to talk to, and only the things it should be able to talk to. So a little example here. Let's say one of our web servers becomes compromised, some sort of vulnerability in our web application. If that machine then tries to, with the network layout we've got here, if it then tries to leverage a network attack to pivot horizontally and take other machines in its tier, by the configuration we have here, which is not a super complex configuration, it's a pretty straightforward set of rules, that traffic is blocked. And if you're using some of the logging features we're going to talk about, that traffic is logged, and you can see that that traffic was blocked. And if it happens a lot, you might take some sort of automated action. So next, VPC subnet ACLs. We'll be very quick on this one. I usually recommend that people use these as a second layer of enforcement or a way to do separation of concerns. They support allow and deny rules, but they're stateless and they apply at the edges of VPC subnets, a lot like traditional network ACLs would on a router. So they can be a little more difficult to manage because that means any of your ephemeral ports for return traffic you have to explicitly allow. So some really powerful patterns we see people use these for is for bulk enforcement at a higher level, to say things like the DMZ never talks to the on-premise network, and use an ACL to make that enforcement because the IP addresses there are stable, they don't change often. Route tables become another way to do enforcement. And this is something that you'll see in a lot of our best practices. The way I talk about this is think of it, what we've got is the subnet on the right communicates directly with the internet. The subnets on the left shouldn't. They either need to route their traffic through another machine in the VPC, maybe a proxy, maybe a NAT, maybe whatever else. I look at it as a way to give things permission to use networking resources and say, well, these subnets do not talk to the internet gateway. These subnets do not talk over the VPN. And again, do kind of bulk enforcement protection for configuration errors, mistake, or maybe a way to do separation of concerns where maybe one group maintains the route tables and another group maintains the firewall rules. So moving up at a higher level, another enforcement tool is AWS Web Application Firewall, WAF. So WAF is unique in that it's actually enforced. The rules are enforced. It's not a WAF like you would deploy on an instance in your VPC. It's actually enforced at the CloudFront edge out in the CDN. What this means and why that's kind of unique is that you don't have to scale it. So if you make a WAF rule to maybe block some traffic that you don't want hitting your web application, that rule is going to get deployed and enforced out on the edge locations that you don't have to maintain and scale. So this can be an important DDoS mitigation technique for a lot of customers. You deploy the rules through either manually through the console, you can create rules and deploy them, or you use the API back to that automation. So you're back in a mode where you can say, well, as I deploy my application, as I have this application pipeline where I put things out into the cloud environment, I can hook into that pipeline and say, well, as I deploy things, I want to deploy new web application firewall rules that are tailored for the application at hand, that are built around it, and that are actually meant to protect it, rather than starting from a set of default signatures and having to kind of do the hard part of tuning them is very, very tricky. There's also a lot of great integrations for WAF. So some of our partners have rule sets that you can take advantage of to use with WAF if that's something that's useful to you. So next, I kind of lumped these all together and called it traffic isolation. We're going to talk about ways to tunnel traffic, high-level ways to separate traffic between environments. VPC VPN becomes a popular option, usually to connect environments on premise is where we see that a lot, but there's definitely been some interesting customer integrations. Customers surprise us all the time with what they use some of these tools to do. And on the other side is Direct Connect, which allows you to configure, right, one's virtual encrypted tunnels across the internet. The other becomes dedicated fiber if you need higher throughput and lower jitter, or potentially you have a compliance requirement around using dedicated fiber or private lines. So another one is VPC endpoints, and we released these fairly recently. So what VPC endpoints, like a really common pattern was having very tightly controlled networks, but people had resources out in S3. And these environments needed to talk to S3. S3 was the first one that we released the VPC endpoint for. What that often meant was that they had to proxy or filter that traffic at the edge of their network. You know, it was all happening in AWS, but from the VPC's perspective, that traffic had to go out to talk to S3. S3 lives outside the VPC. What VPC endpoints does is it provides a routing target that sort of makes S3 look like it's inside or attached to the VPC, but with some interesting controls built around that. It supports IAM policies, so customers told us, we want this, but we need a way to control what buckets it can talk to. Because some buckets have my content in them, some buckets could be owned by an attacker and used for data exfiltration. I need to be able to say, the application can talk privately to these buckets, but only these buckets. And VPC endpoints gives you a way to do that. You can put IAM policy on the gateway, and you can put bucket policy on the bucket that says what machines, what buckets, when and how. So another one is VPC peering, and this leads to some really interesting architectures that we're starting to see and are really becoming leading practice in a lot of different environments. So VPC peering is a way to say, well, I want to create isolated VPCs. I want to create these kind of micro-segmented architectures like we talked about with the security groups at a bigger scale. I don't want to put all my applications together on one big network where they can cause risk to one another. I want to separate and isolate. So the pattern, quickly you go, well, maybe I'll put them in separate VPCs. What VPC peering does is, frequently they have some need to communicate or may need to communicate with shared services of some variety. So VPC peering lets you peer VPCs together, and you still control them, you still configure all the same firewall rules and routing between them, but it gives you that level of control of what VPCs can talk to which, and it lets you route that traffic in a way that's a little easier to manage. So a common kind of design practice that we're seeing that's working out well for a lot of customers is the idea of building a centralized shared services VPC, that VPCA in the middle of the diagram, and saying in the shared services VPC, I put my antivirus tools and my monitoring tools and my patching and all those things that you need to manage a large environment. Maybe your Chef repository servers end up there. Any of those kind of shared services are good options to put in that center. And you configure an environment where the central kind of security and management services are consolidated, and they can talk to everything and everything can talk to them. But the VPCs around the edge that have the applications in them, whether they be development or production, are isolated. They don't talk to each other. They only talk to the shared services network. Things don't route through the center and back out again. So that gives you a way to do that management and often those centralized management functions that you really need or are even required to have in a way that still lets you isolate applications. So talking a little bit about some logging features. So CloudWatch logs we'll talk about in a couple of places. CloudWatch logs is an option to aggregate logging into a central place and do some neat things with it. You'll see, this is actually a screenshot straight out of my account. So you'll see there's a couple things there, like Lambda by default uses CloudWatch logs to store its logging. The fourth or fifth one down there, I've got auth logs I'm capturing from a couple of my Linux machines, and they're pushed here. And the format of CloudWatch logs, which will be a little bit important later, is like with that auth log, you have a log group that's the type of log is the most common pattern. So the log group becomes, var log auth log, which most of your Linux servers are going to have some variety of that, right? Underneath of that, what you can't see on the slide, if you were to click on that, the next layer down becomes log streams, and then I'll have a log stream for each individual server. So I can drill down into the server, the log, and then go through the log entries in that log, or I can do some things at a higher level and say, well, I'm interested in the auth log across all my servers. I may have 100 app servers for this application if it's scaled out. But that log is kind of consistent across all of them in a way. It has meaningful data that matters across the entire fleet, so I can centralize that and I can do some things with it, like configure metric filters that say, use this regular expression to search all these logs, and every time I get a hit on that regular expression, that's a numerical metric. I want to know how many hits of the word error I have, or how many hits on access denied I have in my authentication log, because if that starts happening a lot, I want an alarm. I want to know about it. I might need to go inspect or take some sort of action. And this gives you a way to do that, and we'll use that for some interesting integrations later. So next is VPC Flow Logs. VPC Flow Logs is a way to get network logging data from all of your instances in your environment. VPC Flow Logs by default goes to CloudWatch logs. I've included a sample down there at the bottom. So source, destination, port, number of packets transmitted, and amount of data. It also includes accept and reject information. So if it was blocked by your ACLs, if it was blocked by your security groups, that's in the logs, and you can expect that. It also goes to CloudWatch logs. So when we talk about that metric filter, you can do things like, maybe you don't want to do this with the DMZ because the DMZ is noisy and it receives kind of trash packets all the time. But on your internal networks with very tightly configured security groups, you can do things like, say, if, from our security group example, if I have traffic that's being blocked between my application servers and my database servers on these sort of internal networks, that shouldn't happen often. If it starts happening often, I've probably got a problem. So send me an alarm so that I can go inspect. At best, somebody's got a configuration error they need to look at. At worst, I've got some kind of activity on my network that I may need to address. So CloudTrail. CloudTrail is a way to do auditing of your environment in AWS, right? Programmable infrastructure means that you can also do programmable monitoring. All of this gets logged to log files that then you can then peruse to see exactly what's happening in your network. We talked about before, the network doesn't tell us when things change. Well, now the network tells us when things change. And we can use tools in the cloud environment to monitor that and take action based on it. This is a trimmed down version of a CloudTrail log. I deleted some stuff to kind of make it clear what was going on. There's actually a lot more data in one of these log entries. But we can see here that somebody created a user. Creating a user is within the hypervisor infrastructure, right, at the cloud level, is something that in most organizations doesn't happen too frequently. So that may be something that you want to specifically call out and monitor. I don't create IAM users every day. I might want to put a ticket in or some sort of monitoring to review that after the fact and make sure that it was done correctly. So some more logging options. Elastic Load Balancers, S3, CloudFront, right, all provide access logs. You can store all those logs in an S3 bucket. You can use that to do automated things against them. So next we'll talk about change control. We'll advance this because we're moving a little slowly here. So as resources change, AWS Config monitors the changes of those resources. It normalizes them and kind of sorts out, as it does its kind of scans throughout the day. It monitors those and normalizes that down into what resources changed and how. And it stores that and it allows you to consume it in a couple of different ways. You can get a view of what my configuration looked like at a point in time. You can get a stream of those changes. You can get a history of what did this resource look like in various different versions. Another popular change control technique is CloudFormation. CloudFormation is programmable infrastructure. Infrastructure is code kind of wrapped into a service that lets you write templates that deploy AWS resources. So a pattern we see a lot with this is organizations will use it as a type of change control for infrastructure and say, well, these templates, we treat these as code. We check them into code repositories. Whenever we make changes to the environment, that's how we keep track of what things were. All the changes were done through the templates. Well, a set of features we released recently that's a really powerful way to do that is change sets. Rather than making the change and deploying the template, the idea that you can deploy a change to that template and CloudFormation will tell you exactly what resources it's going to change and it will stage them. And it's a separate API call to actually execute the change stack. What that means is you get another opportunity if you want to do separation of duties and say, well, these people that develop the application can stage changes, but this group over here is who has to execute them. And that doesn't necessarily have to be a manual process. It's all an API. So you could automate that and say, well, really in these environments, the only requirement is that you actually have to put the ticket into change control to log that this was done, and then that system will automatically trigger the API to do an execution. It could take seconds, but you've still forced the change through change control, so you've got visibility and monitoring of it, for example. So a couple examples of making use of logs. I borrowed these examples from another good talk from re:Invent last year that's called Wrangling Security Events in the Cloud. It's available on YouTube if you want to dive deeper into this and see some more cool integrations. You can go check that out. So one is monitoring logging status of things. So we talk about CloudTrail and how important it is to a lot of customer organizations to audit the infrastructure. In this case, we want to monitor very closely if maybe CloudTrail gets turned off, right? So those CloudTrail events can be sent to CloudWatch logs, and we can configure one of those metric filters we talked about before and search those logs for the stop logging action. And if we see that action, we can trigger an alarm. Nobody should turn off audit logging. If anybody ever turns off audit logging, we really, really, really want to know about that. If you're into IoT stuff, maybe that's an actual air raid siren, right? Monitoring for unexpected network behavior. Same kind of thing. We hinted at this earlier, right? VPC Flow Logs can be sent to CloudWatch logs. We can set up filters to say, well, I want to search that log of traffic. I want to look for rejected packets. Maybe not on my DMZ, because I get a lot of rejected packets to my DMZ. I assume you do too. But within my environment, that shouldn't happen often. I shouldn't have a lot of rejected packets between my database servers. That probably means something's up if that starts happening. And the same kind of thing. At some sort of meaningful rate, I want to take automatic action. I want to say something's going on in this network that a human needs to go and inspect. Or maybe I don't. Maybe I'm worried enough that I'm going to configure this for automated action. If this machine violates its security group enough times in a period of time, shut off network access to the instance, preserve it so that I can do analysis of what's happened. Just assume that we need to stop this and deal with it. So watching for disallowed configurations is another possible example. So with AWS Config, Config supports something called config rules, which let you write rules that define how the infrastructure should be configured. And if ever the infrastructure is configured to violate those rules, you can take some sort of action on it. So in this example, maybe no production servers are supposed to have SSH open to the world. We don't allow that in our network, perhaps. If somebody does configure that, I want to send an email alert to the security officer to say, hey, somebody did something bad. This is a disallowed configuration. Don't pick it up 9 months from now in the audit. Deal with it right now. Go talk to this person and say, you're not supposed to do that. That's a disallowed configuration. You need to go out and correct this. Another option, again, is you can trigger Lambda functions from these. So you could use that to take some sort of automated action, like if somebody configures that rule, delete the rule in 5 minutes and take it right back off the group. This is a disallowed configuration. It's not going to be allowed to persist in the environment. We're automatically going to roll that back. Kind of one last look is with VPC Flow Logs, another powerful integration, and there's some good blog posts on this, is that you can push that data into Elasticsearch. So a lot of enterprising groups are using this to push all this into Elasticsearch and put Kibana in front of it, which if you're not familiar is a really kind of flexible dashboarding solution. So that sort of dream a lot of us who've ever kind of managed networks had of, I wish I could have a network dashboard that showed me across my entire organization what's being allowed and denied through my firewalls. I want the big giant wall of screen that shows what's happening in the network like in the movies. Well, you can build that now, and you can build it fairly easily. It takes less than an hour. You can get this rolled out in an environment. So we talked a lot about some very low-level networking tools, and we've kind of talked a lot about automation. So all of this can be automated. So what does that do for practices in the cloud? And I'm going to hand it over to Dave to talk about that part.
Thank you. Hi, I'm Dave. So I work at the UK Ministry of Justice. Excuse me. We use a lot of the tools that Nathan was just describing. And it's an amazing toolkit. It allows you to automate a huge number of things related to security and infrastructure. But in some senses, it's not quite as easy as that. Because what you will discover is as you start to use these automated tools, your practices have to change along with that. And to some extent, so does the culture of your organization. So what underpins being able to use the tools that Nathan was describing is continuous delivery. That's the kind of absolute foundation of all of this. Continuous delivery is quite hard to describe briefly, but I often think the biggest signifier of continuous delivery is that you're delivering into production in minutes rather than months. So your timescales have shifted around. Anyone who's worked with kind of extensive kind of legacy systems will realize that the timescales are considerably longer. You will typically see things like change control procedures. The language of ITIL will prevail. And in some senses, change is feared. Change is seen as something that's scary and needs to be controlled. In a continuous delivery environment, that kind of flips it around and says, we're going to change all the time, and that's normal. And the tools that Nathan was describing underpins that. So in one area of what you might call continuous security, in the area of prevention and response, you've got continuous delivery as the foundation, but there's a whole additional set of practices that you can start to bring in to enable this way of working. So I'm going to walk you through some of those. So continuous security testing. Anyone who's worked a continuous delivery environment will realize that in order to get that to work, you've got to extensively test every single change that you make. And security is no exception to that. Although it is something that often people miss out from their continuous delivery pipelines. There's a huge range of tools and techniques you can use to grow the confidence and the security of the changes that you're making. You can automate things like OWASP ZAP or Burp Suite. You can do static code analysis. You can layer in all these different tools that will start to probe and investigate the changes that you're making and ensure that you're not making mistakes that will introduce vulnerabilities into your code. At the Ministry of Justice, we continuously hack our systems as we build them. We employ people as ethical hackers, and they sit alongside our development teams, and as we build things, they try and break things. They also happen to be the experts in telling us how to do automated security testing, but sometimes it gets to a point where a manual investigative or kind of attacking mentality approach to trying to break your system is really, really helpful. But because they're working alongside the development teams, you don't get that kind of really damaging relationship you can get if you leave your penetration test to the end of your development and you outsource it and a report is produced and it's handed over to your teams. And it can be a bit of a kind of affront to people's egos when they see, oh, here are all the mistakes you made. If you've got a hacker working in your organization alongside your development teams, you get a fantastic relationship between the two. They start to understand each other's mentality. The developers up their game. The hacker responds by doing more interesting tests. And it's quite a kind of creative and empowering approach. Oh, missed one. Continuous risk management. So you can see how all these kind of practices that we used to think of as we have to kind of stop the world, do our deep analysis and understand our system and give it a kind of green tick. If we're enabled by tools like the tools that Nathan was describing, it changes the game. Everything's got to start to be continuous. So with risk management, what we're doing at the Ministry of Justice is we're using many techniques, maybe about 50 different techniques to assess risk. So that's both identifying risk and mitigating risk. and you kind of layer those different techniques on top of each other. One might be as simple as a very simple checklist that a kind of Scrum team will use that checklist every time they complete a story. It might be something that the team runs every sprint. It might be something a little bit more deep and analytical that you run maybe every single crucial architectural turning point. But we've got to stop thinking of risk management as something where we have to do a very lengthy activity at a single point in time and start doing smaller, more granular activities that fit the pace of this new way of delivering systems. Then you've got continuous compliance. Now, this one is really, really hard. Ultimately, the compliance industry is not really engaged with the idea of an extremely continuous way of working. But I think it's something that if you're working in an organization that is subject to compliance, I think you've got to find ways of making the approaches you take to compliance fit that continuous pattern. So again, it's taking that granular approach, that modular approach. It's important that you focus the compliance on your processes and your people rather than the technology itself. It doesn't really make sense to, in a world where you've got continuous delivery, to make sure that your technology complies, because your technology is always changing. The thing that really matters is the way in which you're delivering your systems. Then you've got the detection side as well. So Nathan was talking about some of these techniques, the kind of underlying technologies that enable them. But it's ensuring that we can continuously detect intrusion, that we're continuously checking the health of our systems. We're using monitoring systems that don't just check that systems are up, but they actively work through and process transactions on our systems using fake data or fake accounts. We really need to constantly probe and assess the health of our systems. We want to detect anomalies. Anomalies, I think, I find really quite fascinating, because anomalies in your system are very domain specific. You really need to understand what is a strange transactional behavior in the system that I'm building. And really, it's only the domain experts that can understand what those anomalies are and build them appropriately so that you're not receiving a huge number of signals all the time that are kind of false positives for strange behavior. Continuous capacity management. There are so many different things that can reach capacity in your infrastructure. And to be able to detect early and anticipate when change needs to happen. Obviously, working in a cloud environment transforms capacity management quite a lot, and you can do elastic scaling and so on, but you will still reach limits in every different area of your infrastructure, and you need to be able to anticipate that and then very immediately make the changes necessary to address that. And continuous scaling, which is really about auto-scaling, but also other techniques that apply to the different aspects in which your system will need to scale. Now, what's so important here is that with all those techniques you've got for continuous detection, it really needs to be underpinned by the ability to be able to continuously prevent and respond. You need to be able to deliver changes to your system in response to the things that you're detecting in the production environment. You need a very, very fast feedback cycle. Now, the reason that feedback cycle is so important is because the cyber security threat landscape is changing. The threats are increasing from various different threat actors, and we need to be able to identify when vulnerabilities exist in our system or when an attacker has exploited our system and respond very, very quickly to that. If you have very sensitive data, like we do in the Ministry of Justice in the UK, we have a responsibility, I think, to move towards this continuous way of working so that we can be very, very fast at reacting to security incidents. The problem is that continuous delivery is really, really hard. So we have the tools, we've got the toolkit and the technology, but what happens when you try and do it? So DevOps a lot of people perceiving DevOps now, maybe it's kind of reached a point in a hype cycle where people are a bit frustrated about hearing about it all the time. But as a cultural practice, it is the thing that underpins continuous delivery. If you have barriers between your development teams and your operations team, if you have antagonism, if you have an undue amount of process, too much friction, then it really undermines continuous delivery. You might be using Amazon Web Services, you might have the best toolkit in the world, you might be able to do zero downtime deploys, You might be able to do a huge range of technical approaches, but if you haven't got the people and the mindset to work in that continuous fashion, then none of that's going to work. So the reason why I think DevOps is hard, and therefore continuous delivery, and therefore trying to get the true benefit from a lot of what Nathan was describing, is because DevOps is about culture change. So why is DevOps about culture change? It's because in your organizations, to get this right, if you're moving from an environment where you're working with more legacy technology, you're working with lengthy change control, and you're moving towards DevOps, you're going to need new skills in your organization. People are going to have to learn new methodologies. Teams are going to have to start using new methodologies. Things like agile methodologies, Scrum and Kanban, just to name the obvious ones. People might have to start working new hours and new working locations. A developer that used to go home at 6 p.m. might be asked to come in the evening and support the application that they wrote the line of code that caused the problem. There's new careers. In the Ministry of Justice, we've got new careers, things like ethical hackers, things like web ops engineers, which is a new skill set focused around infrastructure automation. New ways of thinking. You're taking all those well-established practices like risk management and change control, and you're saying you've got to develop new ways of thinking. You've got to kind of reinvent your profession in a way. Obviously, this way of working does affect planning, governance, finance. Everything becomes a little bit different when you work in a more continuous manner because you're not embracing the idea of long-term planning. You're embracing the idea of being able to inspect and adapt and move in any direction rapidly. And I put this silly one at the end about clothes. What I'm trying to say here is that if you really embrace DevOps in the organization, you will get unpredictable effects on your culture. It might be that you get more Tootsie Pops or cakes in the office. It might be that someone attaches bunting to the ceiling. It might be that people start wearing different clothes. It might be that you have a more diverse workforce. But I do think that if you're making a significant jump from a way of working with technology that is kind of resistant to change and scared of change, and you're moving to continuous practice, you will see a lot of effects and changes in your organization. And just a parting thought. So rising cybersecurity threats, I think, require us to be adaptive, require us to embrace continuous practice. Whereas security conservatism, which is attempting to achieve that stability by restricting change, that's the thing that's going to start to introduce higher risks into your organization. So don't think that being conservative with security is being safe. So I'm advocating that people embrace this continuous practice, take these new technologies that Nathan was describing and many others, and start to move towards an environment where we can address the new cyber risks. Thank you.
We're a little bit over, so we got to clear off the stage, but we'll hang around here or out in the lobby to take any questions.